All right, so the next thing that we're going to take a look at is functions, relations, and also a review of function notation. So we're actually going to cover a couple of sections here. It's going to be 2.1 and 6.6. So let me first start with what is a relation. All right, so a relation is a set of pairs of input and output values that are typically written in the form of ordered pairs. Okay, it doesn't have to be written as ordered pairs. It can actually be graphed as well. All right, but each point on a graph is an ordered pair of an input x and an output y value. Okay, so we have an example here, just the set 0, 10, 0.1, 9.8, 0.2, 9.4, so on and so forth, and this continues on. Okay, so again, any set of ordered pairs is a relation. There are no restrictions set upon what makes something a relation or not a relation. Right. When we talk about domain and range, right? When we talk about domain, we're looking at essentially all of our input or x values, and for the range, we're looking at all the output or y values. Okay. Remember that everything is alphabetical. Domain comes before range, input comes before output, and x comes before y. Okay. So when we are looking at a set of ordered pairs like we have here, looking at the x values, for example, all right, since I have explicit pairs written, I can't necessarily assume that every value between 0 and 0.1 are actually part of the domain. I have to go based on the values that are listed here. So my domain here, really, I can only list the values that are written. I can't assume that the values in between 0 and 0.1 are included. And again, the three dots signify that this does continue on. For a range, then, I'm looking at my y values or the outputs. So for the range, then, we have 10, 9.8, and 9.4. Now, typically when we write domain and range, especially when we're listing out values, they don't necessarily have to come in the order that they appear like I did here. They actually should come in the order from least to greatest. So technically, I should probably rewrite this as 9.4, 9.8, and 10. And again, the three dots to signify that this continues on. Right? It's not necessarily a complete list. These are one and the same. It's just the second here is written in the proper order, whereas the first wasn't in what's technically the correct or proper order. Okay? When we have an equation, domain and range, one of the easiest things that we can do is we can actually do a quick sketch of that particular function, or of that equation rather, and look at what my domain and range should be. So here I've got the equation y equals 3x plus 1. So I'm going to have a y-intercept at positive 1. I'm going to have a slope of 3. Maybe we get a line that looks something about like this. Now, I want to ask myself, what x values for my domain do I have? Does this graph continue on in the left direction and in the right direction without ever ending? And in this case, yes, it does. My linear equation is going to continue on in the left and right directions forever, right? So this is going to be all reals, right? So we can write the capital script R, or we could write all reals or all real numbers. And I want to ask myself the same thing. Do I have all y values? So does this graph continue on in a vertical direction in the positive and in the negative direction? And again, this graph, in fact, does. Okay, and as a result, then, our range is all reals. Okay, our linear functions are going to always have domains and ranges that are all reals, unless there's some restriction placed on it that you're only graphing a certain part of the line rather than the entire line. So if you're graphing a segment, then we're going to have a domain and range that is not all reals. However, if we're graphing an entire line, we're going to have all reals for both. Now, if I take a look at our next example here, I have y equals x squared plus 2. This is going to be the graph of a parabola. And in fact, a parabola that shifts up 2 units. So I'm going to have a graph that has a vertex here at 0, 2. It's going to look something about like this. So in terms of my domain, I want to ask myself, what x values do I have? And again, does this graph go on in the left and right directions without bound? Is there anything that's going to stop it or require this equation to stop? And in this case, again, no, there's not. So for my domain, my x or my input values, the domain is going to be all reals. Now, when I look at the range, however, the range starts my y values here, and it goes in a vertical direction up because this parabola opens upward. I don't have any values down here below that y equals -2. All right, y equals -2 is actually the smallest value I have for my range. Okay, so all of my values for the range are going to be y either greater than or equal to +2, okay, or from 2 through positive infinity, okay, if we're doing inequality or if we're doing interval notation, all right? So again, two different ways you can write that. If you're familiar or comfortable with interval notation, you're more than welcome to use it. Okay, so again here, all of my y values started here at +2 and went up in the positive direction on both ends. There is no part of the graph that's going down in the negative direction, thus I don't have any y values that are less than that +2. So domain restrictions, all right, we need to think about what things might cause us to have something that's not allowable, something that we're not mathematically allowed to do, or it's going to cause some kind of a problem. So typically I have you guys talk with one another at your table groups and figure out what things might cause problems. But since we're doing this in a video, let's talk about a few things. So if I have a square root and I have some quantity inside that square root, right? Whatever that quantity is, and really it could be, x plus some number, okay? Or it could just be an x by itself, right? It could be something times x. Whatever this quantity is, this quantity must be greater than or equal to 0. Okay? Or you could think about it as x plus a. This quantity cannot be less than 0. All right? So this has to be a positive quantity. If we're dealing in the real numbers, I cannot have a square root of a negative. Okay? And when we deal with the xy coordinates, this is the reals by reals axis. I'm not dealing with complex numbers here, so we can't have a complex solution. Okay, so you can think of this one of two ways. Either x plus a is greater than or equal to 0. This is allowed. Or x plus a cannot be less than 0, or whatever that quantity is. And this would be what I'm restricting. Okay, so you can solve this either way. Typically what I do is this top one, where I'll set that quantity greater than or equal to 0. And when I then solve it, what I get in this case would be x has to be greater than or equal to a for us to have a function that's going to work here, an equation that's going to work. If I look at that second example I did here, where I'm restricting it by saying x plus a cannot be less than 0, if I solve it, x could not be less than negative a. And I forgot the negative in the first part there. Okay, what I really want is what is my allowed values for the domain. What are we allowed to actually have? Right, so this is going to be more helpful to us. Now, our second thing that we're going to typically see right now that's going to give us a domain issue, right, is going to be if I have division. So if I have, say, to make it simple, 1 over x plus, let's use b. Okay, this quantity x plus b, I'm not allowed to divide by 0. So regardless whether I have a 1, whether I have an expression, whether it's something else, I still can't divide it by 0. So x plus b cannot equal 0. And when I would solve that, in this case, I would find that x cannot equal the opposite of b. Okay, and I could either write it like this, or I could write it in interval notation. But for right now, let's just leave it as x cannot equal negative b. If I'm restricting a single value out, we're just going to list the values that it cannot equal. Okay. So I'll let you guys think about what type of function, or come up with your own example of a function that's going to have maybe one or even more than one domain restrictions. Okay, and we could talk about those in class tomorrow. All right, so here I've got an equation. I have y equals the square root of x minus 3 plus 1. All right, I want to find the domain and the range. So one of the first things I'm going to do, I'm a visual person. I like to see what I'm working with. So I'm going to sketch a graph here. Okay, if we think in terms of graph shifting, this inside is opposite is going to go 3 to the right, and it's going to go up 1. And this is going to be my endpoint for a square root function. A is positive 1, so it's going to open up and to the right. So I might have something at 1, 2, 3, and 1 right about here. And if I'm sketching, it doesn't need to be precise. I just need to have that endpoint in the right place, and a general idea of what that graph should look like. It's going to look something like this. Now let's think about our domain here for a second. If I look at what x values I have graphed, my x values start here and go to the right, and they will continue going to the right the whole way out through infinity. Okay, so I'm going to have all the x values that are x greater than or equal to 3, or from 3 through positive infinity. And if we think about how I said earlier that we could solve for that, if I take this quantity, x minus 3, and I set it greater than or equal to 0, because this is what's going to give me my allowable domain, and I solve this, I'm going to add 3 to both sides. I'm going to get x greater than or equal to 3, and that's the same interval that I got from my actual graph. Okay? If we look at the range, my range is going to start here at y equals 1, and my y values are going to go up. And even though it's getting flatter the farther it goes, it's still increasing, and it's always going to be increasing, right? So what we get then for the range is all the y values that are greater than or equal to 1, or 1 through positive infinity in interval notation. So let's talk about functions next. So a function is a relation in which each element of the domain has exactly one and only one output or element in the range. Okay, so for every input, I have to get a unique output. I cannot have an input that gives me two different output values. So in other words, I can't have two different ordered pairs with the same x coordinate and different y coordinates. Okay, so when we are asked to look at whether something is or is not a function, when we do this graphically, I'm going to use vertical line test. Right, and you guys probably remember this from Algebra 1. All right, where I'm looking at a line and I can say, well, is there anywhere along this function where my vertical line is going to touch two or more points simultaneously? And in that case, it's a no. Same thing, I come down here to my square root function, and there's nowhere along this entire function where my vertical line is going to touch in two or more points. If I look at my parabola, again, it's only touching in one point anywhere that I go on that equation. Now, if, however, I throw another sketch in here. So let's say we actually had an equation of a circle. Okay, and I've got a circle right about there. Now if I take a look at my vertical line, not touching, not touching, not touching. Here I'm touching one point when I first intersect the circle. But everywhere through the rest of the circle, I'm now touching at it at 2 points. Thus I'm touching it more than one, and a circle is not a function. Okay, it's not a function because it fails that vertical line test, because I have a series of x values where I have different y value outputs. Okay, and the equation of this circle might have been something like x minus, I don't know, let's go 5 squared plus y minus 5 squared equals 2 squared, right? So I have a circle centered at 5, 5, right, with a radius of 4 units, okay? Circles are going to fail the vertical line test. And if I were to solve this, what I'm going to get when I solve this part of the quantity, I'm going to get a plus or a minus. That plus or minus gives me a problem. Okay, so when I solve an equation, if you're looking at a straight up equation and you solve it for y, and you get a plus or a minus, notice none of my 3 examples here do I have y equals anything plus or minus. When we get that plus or minus, when I try and solve an equation for y, it tells me that I'm going to fail the vertical line test, and it tells me I'm not going to have a function. When we look at a series of ordered pairs like we have up here at the top, okay, what I need to do is look at all of my x values and ask myself, do any of them repeat? In this case, no x values repeat here, therefore it has to be a function. There's no way it can fail. Okay, and same thing, if I look at my second set of ordered pairs, in this case, none of my x values repeated, so by default then it has to be a function. Now let's say for the second function here, let's say I had another point. Let's say I had the point 1, 5. If I had the point 1, 5, here I would have had 1, 1, here it would have 1, 5, and because I have 2 different y values for the same x, this would then not be a function anymore. Okay. So again, I already talked about this, but testing for functions, the visual way to do this is the vertical line test. Again, the way algebraically to test for functions is to solve for y, to solve the equation for y, and if you get a plus or a minus, you're going to fail the vertical line test. If you don't get a plus or a minus, you're going to have something that is going to be a function, okay, because there are no y values that are going to repeat for or there are no x values, pardon me, that are going to have different y values for our function. Okay, I was getting on to something else with y values that repeat there. Okay, so another example, y equals x squared, right? Our basic parabola. This is a function. However, y equals, or x equals y squared. This we call sleeping parabola. It's a parabola on its side, but this is not a function because it fails the vertical line test anywhere that x is greater than 0. Okay, so just one more example of a function and something that wouldn't be a function. Also, furthermore, if I were to try and solve this for y, right, I have y squared equals x right now, and if I take the square root on both sides, I would have y equals plus or minus the square root of x. Now think about that, right? This top half up here, this is y equals square root of x. The bottom half here, this is y equals the opposite of the square root of x. Thus, I have my plus or minus, and it gives me 2 different outputs to my graph or to my equation. Thus, I'm no longer a function, right? So I have a couple of these in here that say your term, where you would determine whether something is or is not a function, and find the domain and range, right? I'm going to do it real quick, all right? But I want you guys to try this on your own as well. So if I look here, in terms of my domain, right, I'm going to put a curly bracket here. I'm going to have a -1. I'm going to have 1, and I'm going to have a 2. My range, if I'm looking at the y values, right, we're going to have, and if I can try and get these in order for us, we're going to have a -2, a 0, a 2, and a 3. Now, one of the things that I noticed right off the bat, I have more elements in my range than I have in my domain, right? That's a problem. That means I have more outputs than I have inputs, which also tells me that one or more of my inputs must have different y values. And in fact, if we look, 1, -2 and 1, +3, I'm going to have y values that are different for the same x. So because of 1, -2 and 1, 3, this is not a function. Okay. If we take a look here at these three equations, and I can go through and sketch them. Here I have the first one, I have -2x plus 5, or y equals -2x plus 5. I'm going to have a line with a y-intercept of 5, a slope of -2, and maybe something that looks about like this. Okay, my domain is going to be all reals. My range is going to be all reals, and if you evaluate the vertical line test, this is a function. Okay. If I take a look at my next equation here, y equals the quantity x minus 3 squared minus 2. Remember, inside is opposite, so this is going to have a vertex. It's going to go to the right, 3, and down, 2. A is 1, so it's going to open upwards. So if I go right 3 and down 2, I'm going to have a vertex somewhere about here, and I'm going to have a parabola that looks something like this. My domain here, right, the x values that I have, it's going to be all reals. My range, however, is going to be all the y values greater than or equal to -2 or -2 through infinity. Again, if I evaluate the vertical line test, I'm going to find that there are no values such that I fail the vertical line test. Thus, this is a function. If I look at my third equation here, I have y equals the square root of x plus 2 plus 4. Again, inside is opposite, so I'm going to have an endpoint at -2, positive 4. A is 1, so it's going to open up and to the right. So -2, 4, I'm going to have an endpoint somewhere about here. Right? And this is going to open up and to the right. Right? My domain is going to go from x greater than or equal to -2, or from -2 through infinity. For my range, right, we're going to go from y value greater than or equal to 4, or from 4 through infinity if we're using interval notation. Again, if I evaluate the vertical line test, there are no points on this such that we fail the vertical line test, therefore it is a function. Okay. Function notation. So when we deal with functions, we're going to deal with function notation, right? We're going to see something that's written like this, instead of using y for everything in terms of an equation, where I could write this equation f of x equals 2x minus 3. It could have been written as y equals 2x minus 3. Okay, but function notation is just a different way to represent something that's fundamentally pretty much the same thing. Okay, it is read f of x. So it's the function of the variable x. Okay, one thing that's very important, it does not mean f times x. Okay, multiplication and function notation are completely different from one another. Please do not confuse them. Right? Instead, what you're going to do, you're going to evaluate a function given a particular value. Okay, and you're going to do so by replacing x, or the variable of the function, with the value, and then you're going to simplify the right hand side. Okay, so given my function down here, f of x equals 2x minus 3, I want to find f of 4. So if I want to find f of 4, anywhere in that function that I have an x, I'm now going to replace it with a 4. Okay, so what we're going to end up with is 2 times, instead of x, 2 times 4 minus 3, which is 2 times 4 is going to be 8. 8 minus 3, I'm going to get that f of 4 equals 5. Now, if you remember up here, I just said that f of x equals y. This is interchangeable with the xy coordinate x, y, or x f of x. Okay, input and output. All right, so x here is my input, and the value that I got is the output of my function. So f of 4 equals 5 corresponds to the point on my graph 4, 5. Okay? So I want you guys to give this one a try. Okay? I want you to evaluate f of x equals 3x minus 1 for f of negative 5, f of 1/2, and f of 4. And I want you to see what you get. Okay? We're going to do some of these in class, and we're probably going to throw some quadratics and a few others at you in class as well. All right, you'll also see if you scroll farther down through your notes, there's also a review of known functions, all right, and graph shifting that we're going to talk about because they're going to start coming up in topics again here in the next couple of days. So I'm not going to necessarily talk through that in the video, but I do want you to take a look at that before we come into class. That way you've at least refamiliarized yourself with some of those parent functions that we went over back in 2.6 earlier in the semester. All right. Hope you guys have a good night, and we'll see you tomorrow.